As I've already explained, we are changing a little bit of our focus from recognizing congruence to identifying similarity. So instead of just looking at three of the transformations, rotation, translation, and reflection, now we'll also be taking a look at dilation. As you can see, the two images on the screen in front of you are different sizes. They have been dilated. So how are we going to identify similarity? Please read this with me after 2, 1, 2. Two figures are similar if the second can be obtained from the first sequence of transformations and dilation. Very good. Okay, so there's two things that we need to do. If we are going to recognize whether the first image and the second are similar, number one, we have to identify what transformations would have taken place for one image to end up where the second one is. Well, first of all, if it had to slide or move to the right, what kind of transformation would we call that? Translation. Very good. So there is a translation, and then there is a change in size. And when we have a change in size, what do we call that? A dilation. So we know we're dealing with a translation and a dilation. Now, the other important thing we have to look at is this a proper dilation? Did all of the sides grow larger or smaller proportionally? Did they all grow in the same amount? So what we're going to do is we're going to use a proportion to double check the lengths of all the sides. Now, we've got two different triangles in this situation, and we really have to be very careful to keep things organized. So I'm going to label the small triangle as the small triangle. I'm going to label the big triangle as the big triangle, and we're going to start comparing the corresponding sides. Now, do you guys prefer to set it up as small over big or big over small? Do you have a preference? Okay. I heard more people say small over big. Okay? So all this is going to do is going to keep us organized. What we're going to do is we're going to look at corresponding sides. All right, so can someone tell me one of the sides from the small triangle? All right, but we don't say D and F. We just call it DF, or side DF. Now, what is the length of side DF? 3. It is 3. So I'm going to put a 3 here. Now, what is the corresponding side to DF, or the same side on the new triangle, Maddie? GI. GI, very good. So this side, GI, is corresponding, and we can see the length of GI is 6. So my first ratio, the first half of my proportion, is 3 over 6. Now, someone mention another side of the triangle, please. Let's go with this triangle. DE. So we got triangle D, or side DE, which is 1, 2, 3, 4. All right, and that's the small triangle, so we're going to put that on top. And the corresponding side would be GH, and we have 1, 2, 3, 4, 5, 6, 7, 8. All right, now we want to determine, are these two equal? Yes. They are. 3 over 6 is the same as what? 4 over 8. 1/2. And 4 over 8 is the same as 1/2. So these ratios are equal, so they are proportional, which means what? It means that this side grew by the same amount or the same proportion as this side. And what that means is these triangles are similar. All right, so let's break it down one more time. Number one, we're looking at what transformations get one triangle placed on top of the other. Number two, now we're checking the sides to make sure that it is proportional. Maddie, did you have a question? You say that the bigger triangle is twice the size of the small. In this case, you could, because the scale factor to get from one to the other is, in fact, 2. So they did multiply by 2, so it is twice as large. All right, let's try one more example. Here we have rectangles. Now, what transformations do you think are happening in order for one of these to end up where the other one is? What do you think, Maddie?
Translation.
All right, well, what is the first thing that you think? If we're going from the blue rectangle up to the green one, what has to happen first? Rotation. Very good, Robert. So we start off with a rotation. All right, and then we do notice that there are different sizes, so there's going to be a dilation involved, and there may, in fact, be a translation involved in there somewhere too. All right, now what do we have to do? We have to check the sides. Did this rectangle grow proportionally? So let's double check here. Someone pick a side from the blue triangle. TU. All right, so this side right here. After we rotate that, that side is going to correspond with what side on the green rectangle? ZY. Very good. So TU is 3. ZY is 4. Now, are we doing big over small or small over big? All right, small over big. So the small, it's always a good idea to write this word ratio down. So I have small, which was 3, big, which is 4. Okay? Now we've got to try the other side. So UV is 1, 2, 3, 4, 5, and that's the small one. The corresponding side to UV then would be this one here, which is 7. Now the question is, does 3 over 4 equal 5 over 7? Can someone do that on a calculator? Well, we know 3/4 is what? 0.75? So what's 5 divided by 7? 0.71. So are these two equal?
No.
They are not equal. And because their sides are not proportional, then we can say that these two are not similar. So once again, let's break it down. We're looking at the specific transformations that take place, and then we're examining the sides. We're setting up a proportion, all right, and we're setting up a ratio very carefully. In this case, we did small sides from the small rectangle over sides from the big rectangle to see if they were proportional. I would like you to try the got it on your own. So it should be right there at the top of page 539. Go ahead and try the got it on 539.